Hello everyone, today we will explain tutorial 2 as some of you have missed it due to the cancellation that happened in the last week. So the first thing we have is the data types in the C programming language. So now we'll check the different data types that are available for us to use in the C programming language. The first one is the integer data type. The integer data type will hold the numbers that does not contain fractions, so just the numbers without any fraction or without any decimal points. So to declare a variable from the integer data type, we write it like this: integer x. To initialize it with a value, we can write x equal to 5. These two steps can be done in the same line, so we can write it as integer x equal 5. Let us check it in the code. So we can see here I wrote integer x. I can then write x is equal to 5, or I can write it as x is equal to 5 in one line. This can be done with all the different data types. We need to know how to read an input from a user and how to print the values inside any variable. To read the input from the user, we will use a function called scanf. So scanf will take a parameter, the type of the variable or the type of the input that you are taking from the user, and where you will store the input inside your code. So we can write it as scanf, we open brackets, the double quotes, and here we write the identifier of the type that we are taking from the user. The integers have their identifier %d, so anytime you are dealing with integers, you will use %d. And then at the end, you write where you will store your input. And you need to add the ampersand or the and sign before the name of the variable. Without it, the code will not work. So scanf %d and x. Inside the scanf, we only write the identifier of the types that we are taking. So for example, if I have three variables, for example x, y, and z, I write it as %d, and y, and z. So here the first input will be stored in x, the second input stored in y, the third input stored in z. Okay. To print the value in a variable, we will use the function printf. So printf, as we know from the labs and the previous text sections, that it will take the sentence you want to print, and if you want to take a value from the memory, you need to add the identifier, the data type of it. So here we are dealing with integers, so I will deal with %d, and from where in the memory you will take this value. So here you entered an integer %d, it will take the value that is entered inside the x. We can write the three integers, so you entered 3 integers, %d, 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 and then y and z. So if we run this code, enter 10, 9, 8, you enter three integers 10, 9, and 8. This one is stored in x, this one is stored in y, this one is stored in z. Okay. So the main thing is that in the scanf, we will use the identifier of the variable we are taking from the user. When dealing with integers, we'll use %d, and we need to not forget the ampersand before the value. So for example, let's check if we did not add this one and run 10, an error will occur and the program will not continue the execution. So we need to remember to add the ampersand operator. Okay. This part you will find a thorough explanation of it in the next tutorial, in the next video. Let's check the second data type. Here we have the data type called float. So the float will deal with all the numbers, including the all the real numbers, including the fractions and including the numbers without fractions. So here we store as x is equal to 3.2. So it will store the number as 3.2. Also we can do it in the same line, the same as with the integers. Float x equal 3.2. The same thing in the scanf and the printf. The difference will be that the identifier of the float is percentage %f. So currently we knew that the integers will need percentage %d, float will use percentage %f. And the same thing with the scanf, the same thing with the printf. The second data type, the third data type we have are the characters. So if we need to store a single character, we'll use this data type. It's called char_x. And when dealing with characters, it needs to be inside a single quotes. So we can check here. Character x is equal to a. So we have to add it inside a single quote. So the identifier for the character is percentage %c. So the new identifier we have is for character is percentage %c. This one we'll use it in the print when printing or when scanning, the printf or in the scanf. Okay. Next we have double. Double is the same as float but with extra precision. It also stores the fraction numbers or the real numbers. The difference is that float is using 4 bytes and double is using 8 bytes. So double has double the storage of the float. Okay, it's the identifier for the double is LF. So let's add it in our identifier. So for double we have LF. Then we have another data type called long. Long is the same as integer, but it also store larger range of numbers than the integer. For example, if the maximum in integers is from 0 till 10, then in long it will be from 0 till 100, just for an example. The identifier for the long is percentage %ld. So for long it's percentage %ld. So let's see in code blocks how it's written. So we have integer x, float y, double L, character C, long E. So these are the data types that we currently are dealing with in the C language. The difference between them is just when using the scanf and the printf, you have to know the identifier. So integer percentage %d, float percentage %f, character percentage %c, double percentage %lf, long percentage %ld. Okay, let's go to the next part. The next part is the constant. Constant is the same as a variable, but the difference is that its value cannot be changed. Let's see what does this mean. So here, if I, for example, I have integer x, it starts with 10. Anytime in the code I can do this. I can write x equal 5. So I change the value of x. But with constant, the value cannot be changed. If I assign when I assign an initial value to it, it cannot be changed in the code. So how can we define a constant? The constant is written above the integer main. So it's written here, hashtag define. You will give the name of the constant. Let's say we need to calculate the area of a circle. So when calculating the area of a circle, I will need the pi. And we know that the pi, the value of it will not change within the code, so we can use it as a constant. So here, pi, let's set it as 3.14. So here I defined a constant with the name pi and value 3.14. How to use it? You can use it normally as a simple variable. So let's calculate the area. The area will be pi multiply, let's say the radius is 4, so 4 multiply 4, then print the area and run the code. It will calculate the area. You cannot do this, so I cannot say pi is equal to 10. If you run the code, it will give you an error that this one is a constant and cannot be changed. So as it is a constant, I cannot change it. So the difference between a constant and a variable, the variable is defined inside the main and can be defined outside the main. The constant should be defined outside the main. The variable, its value can change anytime in the code. The constant value cannot change anytime in the code. It will only take the initial value that we assigned to it. So here the constant are declared before the main function, and note that any constant value will not be changed. Okay. So any variable consists of, so here, the data type and the name of the variable. This name of the variable is called the identifier of the variable. There are certain rules that we should apply when naming the variable or the identifier. The valid rules are the uppercase letters, the lowercase letters, the underscore, the dollar sign, the numbers at the middle or at the end of the identifier. So if I have, let's talk about the last rule, numbers at the middle or the end of the identifier. For example, I can call it area 1. I can call it ARE1A, but I cannot call it one area. This will give me an error. So the numbers can be available at the end or at the middle of the identifier. Okay. The invalid identifiers are the operators. I cannot use any operator inside any variable. Special characters, the small, greater than, small than, semicolon, comma, the quotes, the brackets, all these characters cannot be used inside identifier. Only the underscore and the dollar sign can be used. Spaces, I cannot use any space. Reserved keywords, the keywords that are already available in the language. So for example, the int, main, float, character, those are the reserved keywords of the language, so I cannot use them inside any identifier. And the numbers at the beginning of the identifier. So let's take here for example A, B, and the and is a special character, so this is invalid. Float is a reserved keyword, so this is invalid. Area of triangle is valid. Equation number #2, the hash is a special character, so this is invalid. Count, valid. X modulus, the modulus is an operator, so it's invalid. R underscore area, underscore is a valid character, so this is valid. $3 speed, this is invalid due to the 3, as the 3 is at the beginning, so this is invalid. Employee dash salary, the dash is a special character, so this is invalid. Okay. Next we have the arithmetic operators. The arithmetic operators are the plus, minus, multiply, divide, and the modulus. We need to talk about this part. What does this mean? All the operators are the plus, minus, multiply, and divide can be done between integers and float. So if I have an integer with an integer, the result will be an integer. Integer with the float, the result will be float. Float with an integer, the result will be float. Float and float, the result will be float. We need to take care of this during the division, as this will raise some issues that we'll discuss when doing the operators. Okay. The mod or the percent is only valid for integers, so it's only integer, and the result will be integer. How we calculate this remainder? Let's take an example. For example, I am doing 10 modulus 4. So I divide 10 by 4 and I want to calculate the remainder of this operation. To calculate the remainder, you will get the largest number smaller than 10, which is multiple of 4. So calculate the largest number smaller than 10, which is a multiple of 4. Then get the difference with 10. So what is the largest number smaller than 10, which is multiple of 4? It will be the 8. The difference between 10 and 8 is 2, so the answer is 2. Let's take another example. So 15 modulus 3. What is the largest number smaller than, you can add here, or equal? What is the largest number smaller than or equal to 15, which is a multiple of 3? It will be 15. So any number that is divisible by the number, the remainder will be 0. Okay, let's take another example. 13 modulus 3. The largest number smaller than 13, which is multiple of 3, will be 12, so the remainder is 1. We can use the remainder, for example, to know if a number is even or odd. So if a number is divisible by 2, it will be even. If a number is not divisible by 2, it will be odd. For example, 14 modulus 2. 14 is divisible by 2, so the remainder is 0. So if the remainder is 0, the number is even. 13 modulus 2 to be equal to 1, so it is odd. So if the remainder with 2 is 0, the number even. If the remainder is 1, the number is odd. Okay. The result of any remainder operation can have some values. So for example, if you are doing x modulus y, the result will only be from 0 till y minus 1. So for example, if I'm doing any operation with anything x remainder to 10, so the answer can only be 0 or 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is just for you to know that any remainder operation, the result will be the number from 0 till the number minus 1. So that you can just calculate what the result will be, or to know if your answer is right or not. Okay. We will come back to this part when we'll do the examples. But first, let's know the precedence or the rules operator precedence. Some operators have higher priority than other operators. So the higher priority or the highest priority is the brackets. Then the multiply, divide, and modulus have the same priority. Plus and minus, same priority. So the brackets is the higher priority. Multiply, divide, modulus in the middle. Plus and minus is the lowest priority. And what we'll do if we have, so you have to do the higher priority ones first. But if you have operations from the same priority, you evaluate it from left to right. Let's take some examples. So if we have 10 multiply 3 divided by 5. So here I have 10 multiply 3 divided by 5. The multiply and the division, multiplication and division, have the same priority. So I will evaluate it from left to right. The multiplication first, then the division. So it will be 30 divided by 5. Then the answer will be 6. So 10 multiply 3 divided by 5. Multiplication is higher priority than the multiplication and division have the same priority. So I evaluate it from left to right. Evaluate the multiplication first. So it will be 30 divided by 5, then 30 divided by 5 will be 6. Okay. Let's see what will happen if we reversed this, or if you add a bracket. So for example, I will do it as 10 multiply 3 divided by 5, but I will add a bracket for this. So the brackets have the higher priority, so I will evaluate the operation inside the bracket first. So here we have 3 divided by 5. As we said before, if we did any operation integer divided by an integer, or any operation with integers and integer, the result must be an integer. So the plus, minus, multiply and divide, any operation with them, integer and integer, the result will be integer. When a float appears in the operation, the result will be float. So let's get back to our example. 3 divided by 5. 3 is an integer and 5 is an integer, so an integer divided by integer must give us an integer. But here we have, if we did 3 divided by 5, it will be 0.6. But I'm dealing with integers only, so the fraction part will disappear, so the result will be 0. As this is an integer and this is an integer, so the result must be an integer. The result must be an integer. So this one will be 10 multiplied by 0, then the result will be 0. This is why we have to take care when we are dividing integers. We have to know that the integer divided by an integer, the result will be an integer, so we remove any fraction from the result. If it was like this, for example, 10 multiplied bracket 3.0 divided by 5. So here this is float divided by an integer, so the result will be 0.6. So it will be 10 multiplied 0.6, and the result will be 6. I hope this is clear enough. We will take some other examples. Let's take this one. 5 plus 3 multiplied by 4 divided by 2 plus 4 divided by 2. Okay. So the brackets are the higher priority, so we'll do the operation inside the bracket first. So this will be 5 plus 3 multiplied by 4 divided by 6 divided by 2. Then we have multiplication and division. They have the same priority, so we'll evaluate it from left to right. So we do the multiplication one first. So 5 plus 12 divide 6 divide 2. Division, so we'll do it from left to right. 5 plus 2 divide 2. The division have a higher priority than the plus, so it will do the division first. 5 plus 1, and the result will be 6. And this is a similar example, so we can ignore it. Let's do this example and the next one. So two modulus 2 plus 2 multiply 2 minus 2 divide 2. So the modulus, the multiplication and division all have the same priority, but we'll evaluate it from left to right. So 2 modulus 2, the 2 is divisible by 2, so the result will be 0 plus 2 multiply 2 minus 2 divide 2. Then we'll do the multiplication. 2 multiply 2 is 4, so 0 plus 4 minus 2 divide 2, then the division have a higher priority, so it will be 0 plus 4 minus 1, and the result will be 3. Let's take the next example. 3 divided by 5 multiply 7 divided by 4. The multiplication and division have the same priority, so we'll do the division first. 3 divided by 5, this is an integer divided by an integer, so the result will be an integer, so it will be 0 multiply 7 divided by 4. Multiplication and division same priority. We'll do the multiplication first as it is in the left, so 0 multiply 7 will be 0 divided by 4, so the result will be 0. Okay, so let's check the logical operators. Like this, we have finished with the arithmetic operators, and now we will check the logical operators. Logical operators are used to compare or to evaluate two expressions. So the two expressions or the two conditions, let's see the different types. We have the logical AND, logical OR, and logical NOT. The logical AND means that I need the two expressions to be true for the whole expression to be true. So it will only return true if both conditions are true. So both conditions must be true for the result to be true. So if any of the condition is false, the result will be false. Only it will be true if both conditions are true. One more thing, in C, true is any non-zero value and false is the zero value. So if you have a non-zero value, it's true. If we have a zero value, it is false. So here, for example, if I have a 0 and a 0, which means false and false, the result will be false. False and true, the result will be false. True and false, the result will be false. True and true, the result will be true. And the default of true is 1. Okay, so the logical AND, it is denoted by the double ampersand or double AND sign, which is shift 7. So we need both conditions to be true for the whole condition to be true. This will be used when we are dealing with the if condition, which we'll talk about in the third tutorial. Then we have logical OR. Logical OR returns true if either one of its conditions are true. So we need only at least one condition to be true for the whole condition to be true. So it will only return false if both conditions are false. So false and false, it will return false. False and true return true. True and false gives true. True and true will give true. So the logical OR is denoted by the double signs or double OR operator. You can find it above the enter. It is the shift with the forward slash. So it will return true if either one of the conditions is true. The logical NOT will reverse the true to false and the false to true. So it will only have one operator or one operand. If it is false, it will give true. If it's true, it will give false. And as we said in C, the true is a non-zero and false is 0. Okay, let's take some example first and then return to this part. So here, for example, I have 5. Yeah, let's talk first about the comparison operators. These comparison operators we will use when we want to compare two different values or two different variables, or a variable with a value. So we have greater than, less than, greater than or equal, less than or equal, equal, and not equal. This one is one of the most important, and we need to know what is the difference between the double equals and a single equal. A single equal, for example, if we write x is equal to 5, this means I'm assigning 5 to x, so I'm assigning the right hand side to the left hand side. But if I wrote x equal to 10, so this means I'm asking a question. So here I'm assigning the right hand side to the left hand side, and here I'm asking if x is equal to 10. So here I'm asking a question, is x equal to 10, yes or no? And here I'm assigning 5 to x. So this is the difference between equal and the double equal. Okay, so let's do the examples now. So we have 5 greater than 2 or 2 greater than 5. So is 5 greater than 2? Yes, it's true. So the result is 1, because we said that 1 is the default value for the true. Then is 2 greater than 5? No, it's false, so it will be 0. Then 1 or 0, which means true or false, the result will be true. Okay, so let's check this one. We need to take care of the brackets, so this one have higher priorities, so we'll do the inner bracket first. So 5 greater than 2 or 2 greater than 5. So is the 5 greater than 2? Yes, so it will be 1. Is the 2 greater than 5? No, so it will be 0. So 1 or 0. Let's check the other side. 5 minus 3 greater than 4. 5 minus 3 is 2. Is 2 greater than 4? No, so it will be 0. So we have 1 or 0 and 0. And don't forget that we have a not at the beginning. So let's write the operation that we have now. We have 1 or 0 and I think it was 0. Yes, 0, and all this inside a bracket and a not. So let's do this one. 1 or 0, it will give us 1, so it will be not 1 and 0. 1 and 0 will give us 0. 0, and then as we have not, so it will give us 1. So 1 or 0 means true or false, so it will be true. True and false will be false. Not false will be true. So don't forget that the not reverses the true to false and reverses the false to true. Okay. Let's now talk about ternary operator. Ternary operator is a shorthand for the if conditions, which we'll talk about in the third tutorial. So this one I'm asking a question, and if the answer is true, I'll do something. If it's false, I'll do the other thing. So the syntax is, I write the expression, question mark. The one here, I'm writing the value if the expression is true, hyphen the value if the expression is false. Let's see an example. So for example, let's say I have integer x equal to 10 and y equal to 20, and I need to know which one is the maximum. So I have maximum and I want to know which one is the maximum, so I can use this ternary operator. The ternary operator, I will ask a question. If the value is, if the expression is true, I will use the first value. If it's false, I will use the second value. So let's say I want to know if x, which one is the maximum. So if x is greater than y, what does x greater than y means? It means that x is the maximum. So here I'm asking a question. Is x greater than y? If yes, take the value of x. If false, take the value of y. So here x is greater than y. Yes, then the maximum is x. False, then the maximum is y. So let's print and check. Sorry. Let's write the code again. So integer x is equal to 10, y equal to 20, maximum is equal to x greater than y, question mark, x, y, and print the maximum is percentage d maximum. Let's check if it's working right. Run. Give us the maximum is 20. So here we can write any condition, any condition using the comparison operators and using the logical operators. I'm asking if the condition is true, I will take this value. If the condition is false, I will take this value. So let's take another example. For example, I need to find the minimum. So I convert this to minimum. And let's make it minimum and minimum. So how to know if x is smaller than y, this means that x is the minimum. Else it will mean that y is the minimum. So we run, it has to give us 10, the minimum is 10. So let's check the last example that we have here. 5 not equal 7. So is 5 not equal 7? True. So I will take this value, the 65. If this operation was false, then I will take the 23 plus 50. So is 5 not equal 7? True. So the answer will be 65 as this the first value. So here the first value is the one I would use if the expression is true. The second value is the one I will use if the expression is false. And by this we reached the end of tutorial 2. I hope that you all understand what was explained. Please comment or write any question you have on the group or on the video, and any one of the TAs will answer your question and give us your feedback regarding the videos to improve the next videos that will appear. Thank you.